Good afternoon. That's what COVID does to you and eating at home. My name is Sanjay. I am the Senior VP for Business Development at Huawei and also the Global CTO. I'm an Indian, Singaporean, working out of Dubai. Spent my early days in the US working on semiconductor fab plants, nuclear power plants, and air traffic control centers, building mission-critical stuff. Got involved in the early colos, KPN Quest in Amsterdam, Exodus in Europe, in Australia, until 2002, 2003, when we had all the dot-com, the bubble burst. And then in the last decade and a half, once the data center industry has come up, it's been quite a journey. The last 3, 4, 5 years have been very interesting, as we heard from other speakers, and I think the story continues. Whether you talk about UAE, AI, cloud-first strategy, digital Malaysia, Saudi 2020, smart Singapore, these are all digital transformation initiatives that the countries have embarked on to improve the quality of services that they can deliver to its populace, or as Singapore calls it, make life more convenient. In the last few years, multiple technologies have come together, which is very unique in these times. We have the promise of cloud computing. I don't need to get into the details, but whether you're looking at traditional companies like Progressive Insurance using chatbots on cloud to service customers, which is what you get every time you call, you think you're speaking to really someone, it's a chatbot. Or born digital companies like Spotify, the embracement to cloud is universal. And what that is doing is basically creating this rapid increase in the demand for compute, storage, and networks globally. If you then couple it with 5G and AI, that is completely bringing us new innovative models, and we believe that will provide the sustainable future in terms of new business models, new services, new revenue streams, of course, through innovation. And then when you look at some of the markets like Latin America, Africa, Asia, there's a concern of digital sovereignty. Governments are emphasizing and enforcing internal data, financial data, to be stored closer to point of use. And this has led to a scramble to either build data centers or lease data centers, whatever is available. In short, there's a lot of demand in the data center space. We believe 1 million cabinets are getting added almost every year globally. Now, I won't get into the numbers. In the morning, CBRE presented a unique perspective on Europe. But this whole data center business is going to grow from 12 gigawatts globally to about 25 gigawatts in the next 5 years. And this puts us at a crossroad in terms of the climate change and the carbon reduction targets that the countries have put upon themselves. It's very important that it's very important for data center owners, operators to be able to comply to some of these requirements. On one hand, we are seeing countries where the digital footprint, the digital energy footprint of the country is almost 2% of the energy footprint of that country. And then when you come to countries like Netherlands or Singapore, that footprint becomes 8%. So clearly, the climate-conscious researchers are getting into the act and raising the red flags in terms of reducing the carbon footprint. If you then look at what Uptime Institute recently did a survey on, the global average PUE of data centers is 1.59. So clearly, we are at a collision course in terms of, on one hand, we have this tremendous growth of data centers, and on the other hand, we are still struggling in terms of what we do with the carbon from the data centers. Now, when we talk about data centers, we talk about making data centers green, aka sustainable, it's important to look at the life cycle carbon of the data center. The embodied carbon during construction, by using recyclables, by using technologies that help us to have reduced wastage. I think some of the folks from Mercury were talking about wastage during construction, noise, water usage. The second aspect is the life cycle carbon during operations, a big component due to energy usage. And finally, end-of-life carbon or carryover carbon. It's very important to look at this whole carbon cycle, especially if you're going to talk about low carbon through the life cycle. Now, we spoke to many users, developers, hyperscalers, and Huawei as a company, we are also a cloud service provider ourselves. And when we spoke to all our internal and external clients, we got a very simple message. We want to build only what we want tomorrow. We don't want to build too much into the future. And this is, sometimes it may not look very challenging when the demand is very good, as it is right now, but can be quickly very challenging when your vacancy rates are 10, 12, 15, 20%. The second area was renewables. And we're not talking about greenwashing using offsets, as you say, robbing Paul to pay Peter. It's about being able to use renewables, sustainable renewable production, to make the life cycle green. Efficient use of energy. Just because it is renewable doesn't mean we need to waste it. And finally, use of AI and machine learning in terms of smart optimization of resources. Whether those are physical resources in terms of where to put the cabinets and where to put the heat loads, to actual optimization of cooling operating points, temperatures, water pressure, water volume, fan speeds, and so on, to improve the efficiency of the cooling loop. Now, to build a low-carbon data center, we have to ensure it's low carbon by design. And when we started comparing traditional construction technologies with all the other technologies that were available, we found that when you look at the complete embodied carbon, it's not only the carbon content in the concrete or in the steel, but it's about the land usage. It is about wastage. It's about the resources used to construct in terms of water and so on. And at Huawei, we've been working on a prefabricated, pre-fitted concept of building data centers. This allows us to do almost 65 to 70% of the construction in the factory, bring the modules on site, and be able to deliver data centers from hundreds of kilowatts to hundreds of megawatts in 9 to 12 months. Build it in a way which is completely scalable. Build it in a manner which is very flexible to meet the ever-changing demands of the industry. We are definitely in a position where the carbon offsetting requirements, the carbon reduction requirements are juxtaposed with the growth of the data center. And so renewables become very key. Now, renewables are technically unpredictable, especially with wind and solar. I live in Dubai, where the sun is guaranteed most of the time, but we clearly know that this is an energy that is available only for 8 to 10 hours a day. And so energy storage system starts becoming very important. And the combination of renewables, energy storage, providing a microgrid environment, and then leveraging cloud technologies, leveraging blockchain to negotiate price contracts and energy contracts, can really help build a very sustainable renewable energy system. Now, it's very important to understand, I heard a lot of speakers talking about putting UPS power back to the grid, connecting a solar plant back to the grid. It's not as simple. There's something called SCR, short circuit ratios. Power plants have very, very strong ratios, very low impedance. Most renewable energy power generation gear is high impedance equipment. And so, but just by connecting them, you may get power, but you don't get reliable grid systems. So it's all about managing the renewables, not just at a single level, but across the whole grid. That will become very key. Now, data centers are complex. There are so many multiple systems in there. Availability is extremely important. We have seen that by converging the power solutions, by creating electrical pods where the complete electrical system is pre-integrated, pre-fitted, pre-tested, pre-certified, it allows us to reduce the footprint of the gray space by almost 40 to 50%. All of this footprint then moves over to the white space, which is a revenue generator. More importantly is the quality and the consistency that one gets across the geography. So whether I'm building a data center in Nigeria or in Singapore or in Bangladesh, I pretty much get a very similar performance because most of the systems are pre-fitted, pre-tested from the factory and look very standard across the board. Now, it's not only about just power. Water utilization and water efficiency is also very important. Use of airside economizers, efficient heat transfer, optimization of cooling systems to liquid cooling systems, all of this is coming together to create a complete cooling solution for data centers. The biggest challenge is the environment. What works in Saudi Arabia doesn't work in Norway, and what works in Norway doesn't work in Singapore. But when we talk about data centers, we tend to talk about more in terms of a uniform cooling system, which doesn't exist. On one hand, we are looking at how do we ensure that we have IT gear, network gear that can operate at higher temperatures, mind well, without increasing the fan speeds on the servers. To then, how do you extract this energy out? More importantly, in the current context, creating high-density cabinet systems so that there is more localization of heat. And this heat definitely then can be utilized in a much more efficient way. The other thing we found in many of our data center builds is the converged cooling systems helps to reduce the maintenance by almost 25%, both in terms of material and manpower. If you then have the ability to digitally visualize all your assets in the data center with a digital twin platform, with so much IoT that is embedded across the data center, devices, systems, subsystems, you are now able to manage your larger data centers all the way down to edge in terms of assets, in terms of energy usage, in terms of the ability to do predictive maintenance by leveraging all the information that is available. And all of this, we believe, going forward, if you are able to then combine it with an energy cloud, which uses blockchain to negotiate with power suppliers based on the cost of power, based on the carbon footprint of power, based on availability of power, we can approach truly a lights-out data center. Now, let me showcase to you some of the work that we have done. In Bahrain, we built a prefabricated data center, about 2.8 megawatt, to be scaled up to 12 megawatt in about 9 months. I believe this won one of the DCS New Design and Build Awards that year. And then for one of our other clients, we rolled out an edge data center setup across 72 sites. This is where we worked with them and created almost a T-shirt sizing for edge data centers. We came up with a 3 by 3 by 3 matrix. The first 3 was the number of cabinets and the number of cabinets, less than 8, 8 to 16, more than 16. The second dimension was the density, 10, 20, 30 kilowatt per cabinet. And the third dimension was the scenario. You have a building with a room where I can put the stuff. You have a campus with power and the necessary supply systems, but you don't have room, and a greenfield. And so by creating a T-shirt sizing system, what the customer got was standardized order menu system where he can pick and choose depending upon the scenario and deploy them. Average time to deploy between clicking the button to order and actual deployment of an edge site was 9 weeks. So by creating this standardization, we clearly can help our customers in rolling out their infrastructure in a very sustainable manner. We then have the Qinghai data center, which is powered 100% with renewable energy using battery energy storage systems. In fact, last year, we signed a contract in the United Arab Emirates to build a 100-megawatt campus fed 100% by renewable energy, which is fed from a 1.2 gigawatt solar power plant. This data center would probably be the world's first data center campus inside a solar power park. We then are currently building something in Saudi for the Red Sea project, where this is a solar power plant which runs on a 500-megawatt battery energy storage system provided by Huawei, and a data center that is coming in the same campus. So we clearly see companies, countries embarking on this journey and making sure that they are looking at the complete powertrain in terms of efficiencies, renewables, and sustainability. In Ireland, K2 use of indirect evaporative cooling helped the same data center to be transformed into a much lower PUE in terms of operation. And cities like Shanghai, Shenzhen, I'm sure London, Amsterdam, the cost of real estate is ridiculously expensive. In Singapore, most of our data centers are vertical. I think that is true even here in Amsterdam. With space at such a premium, it's very important to build the gray spaces as efficiently, as compact as possible, while keeping them safe, manageable, maintainable, and so on. The Shanghai Cloud Data Center, we were able to reduce almost close to 1,000 square meters across their 2 phases. All of this 1,000 square meter obviously was then moved over to the white space, which is resellable space. While clearly the demand is out there, we've been doing quite well. A lot of firsts in the market. I won't go through every one of them. But we, in the last 5-6 years, are globally #1 in the photovoltaic string inverter business. We now, in the last 2-3 years, are globally #1 in the prefabricated data center business. I today have roughly around 190 to 200 megawatt of prefabricated data centers already delivered and some under construction. And mind well, these are 100% prefabricated. I'm not talking about some of the hybrid data centers where the data center is traditional, but the gray spaces are prefabricated. So clearly, a lot of work has been done here. There's a lot of learning here. We definitely would like to share that with the customers, planners, designers that are here. We at Huawei believe that by combining power electronics and digital technologies, we can truly build sustainable solutions that will help us to build the digital economy of the future. And I leave you with this very interesting quote from an unknown philosopher. Thank you very much, and I'm open to questions. Yes, sir.
You talked a lot about the public sector role and investment in digital transformation strategies. And I'm wondering, you talked a lot about sort of public sector digital transformation. There's obviously a lot of large global enterprises that are also going through some of this same stuff. And I'm wondering how you see those organizations and the economic realities that they're facing with supply chain challenges, with other things like that, some of them in industries that aren't growing as fast as ours. Where do you see them prioritizing sustainability, and how will that influence some of the decisions they're making to drive this kind of infrastructure and the build out and the growth of their business?
So I think, there clearly you can group the countries in terms of some of the leading, nations in the world in terms of digital transformation and where they have reached, and definitely ones that are upcoming and the ones that are, still planning. What we see is that one of the challenges in some of the more developed countries is the fact that you have a lot of legacy systems. And no matter how big your aspirations are, you need to still work through those legacy systems. And in fact, I find the mature markets have a more complex situation than some of the less mature markets, because in some of the middle markets and emerging markets, you basically are designing off of a clean sheet of paper. Having said that, we currently see almost across most of Latin America, most of Asia, including India, for example, almost all services provided by the government are going digital. And so that whole space is so flooded with opportunity. And this opportunity, of course, is being tapped by cloud service providers, hyperscalers, enterprise, SaaS providers, all kinds of applications that are there. And then there are those very unique technologies that are further accelerating some of this adoption, especially by using machine learning with all the data that is available and making more sense with that information. I'll give you an example. In almost every country today, safe city is becoming a very important initiative. You go to any major country, safe city is a priority for most of the cities, most of the regional administrations. When you say safe city, the single biggest investment in safe city is not police, it's not vehicles, surveillance. There's so much surveillance out there which is being conducted. But all of this has to be tapped back into command control centers, into surveillance centers for operation, a lot of software being used, networks that are getting clogged. Today we have edge sites. I'm working with at least about 16 or 17 smart city projects, where almost in every city I have close to 10 to 12 edge sites for every square kilometer, because you have 4K high-definition cameras everywhere. You need a lot of edge capability that needs to be there. So the opportunity is huge out there. Wherever the countries are designing on a fresh sheet of paper, we find they are listening to some of the requirements in terms of sustainability. Efficiency has become like a standard now. I think Netherlands and Singapore entered a moratorium on data centers almost the same year, 2019, 2020. I think Netherlands came out of it very quickly with a policy. Singapore came out of it just last quarter, I think end of 2021. And that white paper clearly says in terms of the energy usage, the land usage, the water usage, and so on, noise, and so on and so forth. So clearly, there are countries who are able to put this part of their initiative, part of their policy making. Africa, Latin America is still on the emerging side. We find them struggling. But then the promise for them is the fact that they have no energy. They have no steady power sources. So going to renewable is an automatic choice for them. Using some of the newer technologies for energy is an automatic choice for them. So it's playing out quite well. In some countries, the policies are driving the actions. In some cases, basically the scarcity of resources is driving the action. The challenge really is in the more mature markets where you have, in many ways, abundance of everything, and you got to pick and choose what works for you best. Long answer to a short question. Well, thank you very much, and you've been an interesting audience. Either I was too good or you were too bored. Thank you.